Hello everyone. In this video, I will be talking about linear regression and correlation. This is an introduction and I will be covering scatter plots and the correlation coefficient. Let's start with a linear review. Recall in algebra that a line can be written as y equals mx plus b. This is the most popular form of a line, and you should recall that m is the slope and b is the y-intercept. So the slope of the line, denoted m, is actually the rise over run, or the change in y over change in x. And keep in mind, this will be important when we will interpret the slope of the line. It tells you how fast y changes over x changes. This will always be the coefficient of x. So it is important to make sure that you look for x first, and then the coefficient on the number next to x is the slope. If the slope is positive, that means the line is increasing from left to right. It's going up from left to right. If the slope is negative, it means the line is decreasing, and again from left to right. B is the y-coordinate of the y-intercept. So it is called the y-intercept as a point on the rectangular coordinate system. This will be corresponding to 0, b. This is where the line crosses the y-axis. So let's see, why do we need to talk about this linear review? In many situations, we have questions and we can answer these questions using statistics. So let's take a look at a couple of questions. Here is the first one. Given two different quantitative variables measured on a population, is there a relationship between them? If so, what is the strength of the relationship? What type of relationship exists? What kind of predictions can be made from the relationship? So in order to answer this type of questions, we are talking in this chapter about correlation and regression and all the statistical terms and procedures that come along with these. But first I want to point out something interesting. This is the first time we are looking at two different variables, and these two different variables are quantitative variables. So keep that in mind. Let's come back here to correlation and give the definition of correlation. Correlation is a statistical method used to determine whether a relationship between the variables exists. So this will answer the question, is there a relationship between those? Now, if we see that there is a relationship between those, it is worth investigating. And investigating this means we will go through regression, because regression is a statistical method used to describe the mathematical relationship between variables. So the first thing we should do when we have two quantitative variables and we are wondering whether there is a relationship between those quantitative variables is to try to visualize that relationship. And we can do this in math by creating a scatter plot. A scatter plot is a graph of the ordered pairs x, y of numbers from a data set consisting of measurements from the two independent variables, x and y. So we are dealing with two data sets. We take one value from one data set, we take one value from the other data set and the corresponding value, and we form a pair. This is called an ordered pair. If you recall, in algebra, we call the first one the independent variable and the second one the dependent variable. And a scatter plot is a visual way to describe the nature of the relationship between the independent variable, and this was x, and the dependent variable, this was called y. In statistics, we will use this terminology. X will be called the explanatory variable, while y will be called the response variable. Here is an example of such a graph. You can clearly see that this is a graph showing a scatter plot used to see if there is a relationship between the number of absences or some students in a class and their final grade. You can see that as the number of absences go up, the grade is actually going down. This is what is a scatter plot. We can do a scatter plot by hand, trying to plot the x values on the x-axis, the y values on the y-axis, and then put a dot for each xy pair. However, we will be doing this with technology, meaning TI-8384 or even Excel does a very good job. And there are some other statistical softwares that do a very good job of creating this type of graphs. Let's take a look at another example. Graph on the coordinate plane where there is 1 point for each pair of data, independent variable and dependent variable. You can see that this has been already done using some form of technology, and this will be based on this information. We have to see if there is a relationship between dexterity and productivity. So if I want to see this ordered pair, and I can add it in here on the graph, the first one is 23, and the corresponding dependent variable is 49. I'm looking at 23 and 49, which is close to 50. So it seems that this dot right here is the corresponding dot on the scatter plot. And you can find 1 point for each one of these ordered pairs. And this has been done with technology, with the TI-83 or with Excel. And I will tell you now how the calculator should be used, actually, because for this class, we'll be using the calculator most of the time. So in order to go ahead and get a scatter plot like that, the first thing you need to do is enter the first variable in one list 1 on your calculator, and the other variable, which will be the dependent variable, or y, in the second list. If you want to try this, you can just plug in those values. After that, you will adjust the window, and then on your calculator, you will go to second y equal, and when you hit that, and keep in mind, this is the place on your calculator where you usually go to enter the equation that you want to graph. But when you access the second, it will take you to this screen. And on this screen, you want to make sure you turn the plot one on. So this is highlighted. And then you will use arrows to pick the correct graph. And you want to make sure you have list 1 accordingly and list 2 accordingly. And then you will simply press graph. Well, when you will press graph, you may not see this graph. So if you follow the instructions, but you miss to adjust the window, you will not see the graph. So you need to adjust the window manually, or you can hit zoom 9 and the window will be adjusted for you, and you will be able to see actually the graph that I've shown you before. And we will actually show you how to do a scatter plot toward the end of this video when I have an example that we need to complete. But for now, you may want to try this on your own. And after you do that, come back here and make sure you have this graph. And I can show you the graph. You may adjust the window though, so you don't see this part of the graph too. As long as you start, instead of 0, you start somewhere close to 20 on the x-axis. Then you can remove this part that you don't need. But for now, we will continue. As you've seen, whenever you look at a scatter plot, you are trying to see if there is a relationship or if there is correlation between the two variables. So you may see something like this, and if you see something like this, now it is clear that you see a linear pattern, and you can see that this is modeled by something that goes up from left to right. So it looks like a straight line going up from left to right. It will be a strong positive linear pattern. You may see a linear pattern like this, but look at this. There is one dot that doesn't belong to this linear pattern. So we will just call that there is a deviation, one deviation. You can have more deviations. You can see a pattern that doesn't look linear, and you will say is non-linear. It can be a different type of correlation, but we are studying linear correlations in this chapter, so we'll simply just say nonlinear correlation. You can see dots all over the place. You see it's no pattern, so you will say no correlation. If a pattern goes down from left to right and it's like on a straight line, you will say, well, that's a strong but negative linear pattern. And if you kind of see a situation when it seems that there is a line, but it's not quite a strong pattern, it's an indication it goes down, but you can see that the dots are kind of far away from where they should be. We're talking about a weak negative linear pattern. So we need a measure to describe the relationship between two variables because scatter plots can be misleading. So let's see what will be a quantitative measure of the strength and direction of the relationship. So I will add right here and direction. The most commonly measured is called Pearson product moment, which is PPMC. This is usually just called the correlation coefficient. So this is what we will be using. Keep in mind, it is the same as PPMC, correlation coefficient. This is denoted by R. The formula is right here. How do we find R? Keep in mind, we are working with pairs x, y. These are ordered pairs. If we find the summation of x times y, and then find the summation of x, find the summation of y, find the summation of x squared, and so on, we should be able to plug in this formula and find R. Now, you probably understand why when you use the TI calculator and you try to find measures under one variable stat, you do see all of these summations. So you can find this R by plugging in this formula. However, because it seems like a tedious type of work, the formula is built in your calculator. And we have better ways. Instead of using this formula, we will simply use a function or a command in your calculator and we will get R right away. And I'll show you how to do that. But let's first talk about the properties of the correlation coefficient. Keep in mind, the correlation coefficient R is computed from the sample data and it measures the strength and the direction of a linear relationship between two quantitative variables. So this R will actually be a statistic. It comes from sample data. This is a number. It's a measurement that measures the strength and direction of the linear relationship between two variables. Now, this number, it's between -1 and 1 inclusive. If the measurement is negative, like the slope, it means that it is decreasing. So the same sign and the same direction as the slope. A negative R, it's an indication that the line is decreasing. It's like the slope. A positive R, it's an indication that the line is increasing from left to right. The closer to 0, more evidence that there is no linear correlation between the two variables. The closer to 1 or -1, more evidence that there is a strong positive or negative linear correlation between the two variables. So if you look at this, we have the -1 right here to the left, +1 right here. If R is somewhere close to 0, then we have no linear relationship. If it's here on the yellow, more on the yellow part, it's a weak linear relationship. The closer it gets to +1, the stronger the positive relationship it is. The more it gets to -1, the stronger negative relationship between the two variables. And I mentioned before that this R is a statistic because it's a measurement that is found by using the sample. And like any measurement, there are two kinds. You may be wondering, okay, if that is a statistic, what will be the corresponding parameter? The corresponding parameter will be the same measurement, but the measurement will be found by using the entire population. And the symbol for the parameter for correlation coefficient is a Greek letter. This will be something new for you. It's called rho, and this is the symbol. It's like an elongated S. The symbol for the statistic, we already talked about this. And again, this is a measurement that is found by using the sample. The symbol for the statistic is R. Why do we need to talk about this? Well, because we will be doing a hypothesis test. to see if there is a relationship between the two variables. And that hypothesis test will be done for the correlation coefficient rho. But before that, let's recall all the measurements that we discussed in this course. We talked about the mean, and the parameter was mu. The statistic was x bar. We talked about sigma, or the standard deviation, the parameter sigma. Statistic was S. Proportion, parameter P, and statistic P hat. And now we have a new one, which is called the correlation coefficient, parameter rho, statistic R. So how do we find R? Using the calculator. And I will show this to you very soon. This is what you can try, or maybe you can come back and try after. You will see how it's done on the next example. You will simply place x values in L1 and y values in L2, and then you will choose a test, which is called linear regression t-test. And under the linear regression t-test, you will be able to find R. There are many different ways you can find R by using the calculator. We will just stick with this one because this one will do a linear regression t-test, will find R, and will find all the other measures that we will be discussing in this course. So if you want to practice with an example, you can put in the X in L1, the number of hours practicing, and in L2, points scored, and do the linear regression t-test, and you should see R displayed there. For now, we are just focusing on R, and this is R. Rounded to 3 decimal places, it's 0.998, which means there is a very strong positive linear correlation between number of hours practicing and the points scored. So let's do that on an example. Here is the example, and we'll be using this example actually to do a lot more. So you will see this example again. Suppose that we want to gauge how college grades for business major affect starting salary in the job marketplace. To this end, we select 7 recently graduated business majors and compare their GPA with their starting salary. We have this data, the GPA X and the salary Y. The salary is in thousands. So keep in mind, usually the first variable is the independent or explanatory variable, and it is. Even here they say X, and then Y is the response variable. But sometimes you'll have to make the decision which one seems to be affecting the other one, okay? So sometimes you need to know which one you put first and which one you put second. That's your decision. What makes sense for that specific study? So for example, because they were looking to see how the grades affect the starting salary, they decided to put the grades first and then the starting salary. So the first question is, which variable is likely the explanatory and which one is the response variable? I just talked about this. X, or the GPA, will be the explanatory variable, and the response one will be the salary, and I explained why it is the purpose of the study, and it's actually based on this word. This is a clue. This is how you can answer these questions. Now it says make a scatter plot of the data using the calculator. Let's grab the calculator. And the first thing we need to do, we need to put X in list 1 and Y in list 2. I have already done that. You can stop the video until you enter this in L1 and L2. And what I need to do next to make a scatter plot, I'll go to second Y. So second Y. And this is the screen that I was talking about before when I gave instructions on how to use the calculator to create a scatter plot. You will need to turn the plots on. So what I will do, I'll simply hit enter here, and I want to make sure that my blink is on. That means this is highlighted. I will turn it on, and look at how many types we have. The first one is the scatter plot. So use arrows to scroll down, pick that one, hit enter, then make sure you have your X values in list 1 and Y values in list 2. And let's see what happens if I hit graph. So graph will be this last option right here on the top. So now I will hit graph, and it seems that I did not really get a scatter plot. So why? Because I need to make sure my window setting is correct. And also I want to make sure I have nothing else on Y, because the calculator will graph whatever we have on Y. Let's just take a look at Y and see I have something in Y. So what I will do, I will just clear this, make sure the plot 1 is on when I do linear regression. But if I don't do linear regression, make sure you will turn that off, because otherwise it will mess up your work in algebra. And I'll show you how to do that later. But for now, I go back to graph and still I don't see any plots. So what I do, I will go to window and I can adjust the window manually. I just look at the type of values that I have right here. GPA from 3.2, that will be one number, up to the largest number. The smallest is 2.21 and the largest one is 3.87. So it seems that I have X between 2 and 4 and Y between 25 and 38. So I'll just put X minimum I set between 2 and 4. These are the GPA. And the salary is between 25,000 and I can put 40,000. Just make sure you don't put that on the scale. That's supposed to be the Y minimum. So the scale was fine as before. Don't change the scale. I'll just put 25,000 and 40,000. And the scale stays the same. And now when I graph, this is how it looks like. Okay. So I have my X values and this one starts at 2, goes up to 4. And my Y values will go from 25,000 to 40,000. I can see there is a strong correlation between these two variables, right? Another way to get the graph is to go to zoom. So if you don't want to adjust the window manually, go to zoom and hit 9, zoom 9, hit 9 or scroll down to 9. And then this will be adjusted right away. So you will see the dots in there, zoom 9, okay? That's kind of a shortcut instead of going through those steps and adjusting the window manually. The next thing I want to do is compute the sample linear correlation coefficient. I can see that there is a very strong positive linear correlation, but let's see how strong it is. I'll go to stats and I'll run the test. That's how I can find this measure. Which test? Linear regression t-test is not on this first screen. I will go up and it is right here, linear regression t-test. So let's hit enter. Do I have my X values in this one? Do I have my Y values in this two? Frequency 1, I have 1 of it. And don't change that, just make it not equal to linear regression equation. For now, I will not store it. You can store it though. So if you want to store it, so you will see it on the scatter plot, this is how you will do it. So I will show you an extra step here because we are at this point, and later on when we will talk about the regression equation, you will see how helpful that will be. In order to store this under Y1, I will simply go to variables, which is this key, Y variables. So use arrows to get to the Y variables. Function, hit enter. I need the function in Y variables and I need a Y1. So this one, this regression equation will be stored in Y1, and I'll show you what I mean by that. And now calculate. So I'm simply running a linear regression t-test. Keep in mind this step with storing the line is not something that you need to do at this point, but just for you, if you want to challenge yourself a bit, you may want to try that, but otherwise skip. And you'll have a lot of information here. And we'll be talking about all of these measures. But as you scroll down, you see R, it's 0.988, which indicates a very strong positive linear correlation between the GPA and starting salary. And we'll talk about the other measures, but for now, just focus on that R, okay? I want to show you something else. If you go to the Y screen, something appeared under the Y. This is the equation, which is called the regression equation. This is actually the line that models the situation. And we'll be talking about this in the next video. I want to show you something else if I graph this. Now, because I have it in Y1, the line will appear on the scatter plot. So this is how it's done. I want to write down the answer right here. We did do a scatter plot. We actually put the line on the scatter plot, and the sample linear correlation coefficient is 0.988, which is very close to 1. So it indicates a very strong relationship between the GPA and the salary of business majors. With this, I conclude the video.